Welcome students. We want to discuss about the velocity and acceleration of motion in the space. So note that the motion in the space, the path in the space is given by r of t. So vector r of t decides the position of your object in the space at time t. Then the velocity v of t is simply derivative of the position, and the magnitude of this velocity vector t will be given as v. Okay. So I'm going to use v without an arrow on top would mean velocity. Now another way to look at the velocity is if we have velocity vector v of t at time t of a point moving along the curve whose position is r of t is basically r prime t, which is limit as t goes to 0 r of t plus h minus r of t over h, which is f prime t I plus g prime tj dj plus h prime tk. Yeah. So this we have already seen when we are discussing about component-wise differentiation. Okay. So now again, the speed is given by length of this vector t, which is p of t. Now, what is acceleration? Acceleration is also a vector. So acceleration at time t is given by derivative of your velocity vector. And if you want to put it as position vector, it will be the second derivative of the position vector. So suppose we are given the following. A position vector of a particle is given by r of t, which is given by the following equation. Find the velocity, speed, and acceleration at time t equals to 2. So first we'll compute r prime of t, which is the velocity vector. That is component-wise derivative. So the component-wise derivative is 2e to the power t times 2, 1 by 2 square root of t, and here we'll have minus 2t upon t square plus 1 the whole square. Yeah, I use the chain rule for the third component. Now we want to compute the second derivative. So first, this is a velocity. So what is the velocity at t equals to 2? It's going to be simply v prime of 2. That is going to be 2e to the power 4, 1 by 2 root 2, and here we'll have minus 4 over t square plus 1, so 2 square plus 1 is 5, so 4 by. So this is your velocity at 2. Now what about speed? So v of 2. So v of 2 without the arrow on top is the speed. So v of 2 is essentially square root of 2e to the 4 whole square plus 1 by 2 root 2 the whole square minus 4 plus 4 by 25 the whole square. So this is the velocity at 2. Sorry, this is a speed at 2. Velocity is a vector, speed is a scalar, which is the length of your velocity. Now we want to compute the acceleration. So acceleration of t at t is going to be derivative of this guy, which is going to be 4e to the power 2t. Now this is t to the power half. T to the power 3 by 2. So this is your a of at t. Right. Now let's look at the following. So position vector of particle that has acceleration a of t is given the following. Sorry, the acceleration is given the following. We need to find the position vector of the particle. All right, so now acceleration goes other way around. So we want to get, so the idea is you go from position to velocity to acceleration using derivatives. And integration, if you do integration, we'll get from A, then you integrate, you get V, from there you can integrate, you get R. Okay, so here we have A of t equals to this, so let's integrate A of t. So this can be also written as 0, 0, minus 10. So V of t is going to be integral of, so first of all, by definition, it's the integral of A of t dt, which is going to be integral of 0 is 0. So 0 plus C1, right? So we can have 0 dt, 0 dt, minus 10 dt. And then this is going to be C1, C2, minus 10t. So we are given V of 0 equals to 1, 1, minus 1. So, and then for the third one also we'll have a constant of integration. So let's say C3. So we have V of 0 is this guy on one hand, on the other hand, by substituting here, we get C1, C2, C3. So this implies V of t equals to 1, 1, minus 10 t minus 1. So this is your V of t. Now we want to get R of t. So first we'll find R of t is integration of V of 0, V of t dt. That is going to be integration of the vector integration. So it is component wise integration 1 dt minus 10 c minus 1 dt. And when you integrate component wise, you'll get, say, another constant. Say in this case I'll use alpha 1, alpha 2, minus 10 t squared by 2 minus t plus alpha 3. Now we need to find out alpha 1, alpha 2, alpha 3 to have a complete profile of R of t. So note that R of 0, on one hand it is 2, 3, there's no k component, so it must be 0. On the other hand, we get alpha 1, alpha 2, 0, right? Alpha 3. So this implies alpha 1 equals to 2, alpha 2 equals to 3, and your R of t equals to 2. Oops. So here, my bad. Here the integration should be what? T plus alpha 1. My bad. T plus alpha 1, right? Integration of 1 is t. So t plus alpha 2. Okay. And then however the whole thing works out the same way. So we have t plus 2. We have t plus 3. We have minus 5t square minus t plus alpha 3, which is 0. So you don't need that. Alpha 3 is 0. So, all right, so now let's look at the following problem. So projectile is fired at the initial speed of 500 meters per second, and the angle of elevation is 30 degrees. So we have a projectile fired like that, and the initial angle is 30. So a projectile looks like this. So this is how the projectile is fired. The initial angle here is 30 degrees, and the velocity v0, which is here, v0, and your velocity v0 is, so the speed of this velocity is 50. All right, we don't know what the, we don't know the vector quantity of it, but it's 50 meter per second. That's the speed. Okay, so now how do we go about this? So if you fire a projectile, what is the force acting on the projectile? So the force acting on the projectile is F equals to mass into acceleration, Newton's law, and that is, there's only one, we are ignoring everything else, there's only one force acting on it, which is the gravitational force. We have mg minus mg because it's downward. So in this case, so now what is my A? So A is going to be minus gj. So what is my velocity from there? I get my velocity v of t is integration of this guy, which is integration of minus gj dt, and that is going to be minus g t j plus a constant. This constant will be constant of integration in vector step. So we get this guy now. So we have C equals to, so we get this guy C. Now we need to equate it to with V0. So now what is my V0? So since all of this thing is happening inside the plane, we will not go beyond I and J. All right. So now what is our V0? So V0 is going to be, so V0 is going to be, how much is in the direction of I is going to be V0 cos 30 plus V0 sine 30. That is going to be 500 times cos of 30 degrees. So we get, this is your velocity at 0. So we get, so this is I, and then the direction of J is going to be this. So cos 30 is going to be root 3 over 2 I, and then this will be 500 sine 30, which is 1 by root 2, 1 by 2 J. So this is our V0. So when we put it back, we get V of 0. On one hand, we get 0, right? Because t is 0, so 0 J, C1, C2, C3. And in this case, again, as we said, it's in the plane, so it's only going to be C1, C2. So therefore we get from there that C1 equals to 500 times root 3 by 2, which can be written as 250 times root 3, and C2 is 250. So now let's put that back. So our V of t is, so we have this V of t equals to, so V of t is 0 in the first coordinate. So, and then because of C1, it's going to be 250 root 3, and C2 is going to be 250 minus GT. Right, so this is our V of t, and now we need to find out R of t. Integration of this, so 250 times root 3 dt, integration of 250 minus gt dt, and when you integrate this you get 250 root 3t, you get 250 t minus gt square plus another alpha 1 alpha 2, the constant of integration. Now note that r of 0 is 0 0. Why? Because we placed our origin, we placed the starting point at 0 0, right? We are hoping, we are starting with the idea that it was fired from the ground because no height is given to us. So r of 0 0 is essentially, so r of t is 0 0 at the starting point. So we have, or in other words, we have r of 0 is 0 0. So this gives us alpha 1, alpha 2. When you substitute, this is also going to be 0 0. So therefore we get r of t equals to, so we got this one. So again we forgot about adding the constant of integration. So r of, so now the first question is, what is the range of the projectile? So to compute the range, we have to basically see when does the y coordinate becomes 0 again. Yeah. So at impact, we get this becomes equals to 0, right? So we have 250t minus gt square equals to 0. This gives us 2250 by g equals to t. Now, why is that? Since t is not 0, right? T equals to 0 is the starting point, so it's not the impact point. So you can take g to be 9.8, so it's going to be 250 over 9.8 roughly. Now, what is the maximum height reached? Yeah, so we'll come to that in a minute. What is the speed of impact? So what is the velocity at t equals to this, right? So we'll have to find out what is the velocity at impact, v of velocity at impact. So velocity at impact is v of 250 divided by 9.8. So that's velocity of impact. The range of projectile is, now range of projectile is going to be is basically how much did you basically move in the x coordinate, right? So it's going to be r of 0. So essentially it's going to be r of the final impact point, which is 250 9.8 minus r of 0, which is 0. So you just need to find out r of 250 by 9.8. And then the maximum height achieved. All right, so for that, we have to basically take the derivative of this y variable to see when is the maximum height, all right, or when is the velocity 0, either one of them, right? So velocity becomes 0 at that point temporarily. So we get, so this should have been g squared t squared by 2, right? Because integration of t is t squared by 2. So this has to be t squared by 2. So then this would have meant that this is going to be 2 times this guy. And that would have meant that it's 500 by 9.8. So the velocity is going to be, in this case, the velocity is v of t. So when I put t equals to 250 by 9.8, so this is going to be, we'll get 2 times 250. So 2 times this, that is going to be same as saying this is 500 by this guy. And then when I sub it in here, I get g, which is 9.8 minus 500 by 9.8 square times half. Okay. So whatever is that value. So this is the range of projectile, and so we got t equals to 500. We get t equals to 500 divided by 9.8. So this is going to be 500 divided by 9.8. Okay. So now we want to discuss about tangent normal vector for acceleration particularly. So recall what was the tangent vector. Tangent vector was you take r prime t and divide by its length. So you get unit tangent vector. So it's called unit tangent vector. And normal is you take derivative of the tangent and divide by the length of it. So you get normal. So now if you take an acceleration, acceleration has two components, namely a tangential component and a normal component. So if this is acceleration, there's a component in this direction, which is tangent to the curve. So this is your curve. Then you have a acceleration, which is in this direction. And the normal is this one here. So we can decompose the acceleration into two components. So let's work on that. So now let's compute this. So suppose we have acceleration A. In that case, we want to find out the tangential and the normal component. So we have, first of all, the tangent vector, the unit tangent vector is essentially r prime of t divided by length of r prime t. But your r prime t is the velocity, so we get, this is same as vector v divided by length of vector v, which we are writing it as just v, which is the speed, right? So therefore we get velocity vector is going to be v times t. Yeah, this v small, this v is the speed, right? This v is the speed. So now let's take derivative again. So this implies a of t, which is your v prime. So again, we have to use product rule here. So v times t prime plus v prime times t. So, or I can write this as, because I want to write t component first, I'm gonna just interchange the order. It's gonna give us the same result. So we have v prime at t plus v t prime. Now we will rewrite this in terms of, so we are using curvature here and velocity. So let's write that down. So here a of t is automatically gotten, right? This is your a of t. That means the component along the tangent and along normal. So let's basically, this is what we need to rewrite so that we can get kv square. So how do we go about it? So first of all, so note that first of all, we have n is same as, on one hand, n is same as t prime upon length of t, right? Because I want to write this as, I want to write this guy as, then this guy becomes the following. This is same as v prime t plus, instead of n, so n is same as t prime divided by this. So I can replace this t prime by length of t prime times n. All right. So now we have, however, t prime is this guy, but what do we have? We have t prime, recall, but recall, what was our k? The curvature k was t prime divided by r prime. That is same as saying k times r prime, which is going to be v, equals to, so we had from early on, we had v, and now we are writing, instead of t prime, we are writing kv. So substituting in, so sub hash in star, we get at equals to v prime vector t plus, instead of now we have v, instead of t prime, length of t prime, we have kv, so that makes it k v square, or kappa v square t prime. Oh, sorry, we change it to normal now. So, and so what is the tangential component? The tangential component is at, the normal component is an. So whenever you have an acceleration, you basically have, you're moving along, there are two forces felt, the normal, which basically moves it inwards, and tangential, which basically pushes it outwards. Okay. So yeah, so in this sense, if your passenger takes a sharp turn, that means the value of curvature is larger, right? So sharp turn, if you take a sharp turn in a car, this implies K is large. This implies what? You feel larger normal component. So this means the larger normal component, basically the passenger will be pushed in this direction. Okay. So another fact that AT can be written in the following form: R prime T times R double prime T divided by R prime T, and AN can be written as this guy. So in the previous one, we saw that acceleration has the two components. So the components of acceleration are V prime T plus K V square N. Now also note the following, that your vector V, as we have seen here, is vector V is going to be T times, so it's going to be velocity, speed times tangent vector. So take V so take V dot A, that is going to be V T dot with V prime T plus K V square N. Now note that T dot T, it's a unit vector, so T dot T is 1, whereas T is perpendicular or orthogonal to normal vector, so we get this is 0. So in this case, what is left out is V prime. We are left out with V prime V. So V prime or VV prime. Okay, so this is your, or in other words, you can write a T, which is V prime, is going to be V dot A divided by, so this implies V dot A divided by V, that is same as R prime T dot R double prime of T divided by length of R prime T. Similarly, let's compute AN. So AN is K V square. Now for curvature, we have already seen the formulation. It's R prime T cross R double prime T divided by R prime T cube. Now multiplied by, so K is this thing, V square is R prime T square. If you cancel these guys off, cancel these powers off, you get the result. So this is your AT, this is your AN. So let's work on the following problem. You have t squared 3t. We want to find out the tangential and the normal component. So which one will be easier? Either we can go about computing these guys, v prime and kv square. For that, we'll have to compute the curvature, or we can use the following formula from here. So in this case, we need to compute r prime, r prime. So let's compute those. So r prime is 1, 2t, 3. R double prime t is 0, 2, 0. So now we need to compute, first we'll compute AT. So the tangential component is R prime t dot with r double prime t divided by length of r prime t. As you can see here, so the dot product of these two guys I can compute on the fly. It's going to be 4t divided by square root of r prime t is going to be 1 square plus 4t square plus 9. So this is 80. Now to compute an, we need to take cross product of these two guys. So an, so first we compute the cross product. So r prime cross r double prime of t, again I j k 1 2 t 3 0 2 0. So I'm not going to I'm going to expand this. I'm going to use the third one, minus plus minus, so this is going to be -2. So forget about this one and this one, so you'll have I1k3, that is going to be -2 3i minus k. Therefore we get an is length of rt r prime t cross r double prime of t divided by r prime of t. That is going to be, so denominator is already computed here, so 4t square plus 10, and the numerator length of this guy is going to be 2 times 3 square plus 1. So 3 square plus 1 is again 10. So this is your an. So we have computed the tangential and the outward into the air to the ground. A west wind applies a steady force of 4 Newton to the ball in eastern direction. Where does the ball land and with what speed? So suppose the ball is basically placed here at origin. Yeah, so the ball is placed at origin. So now what we have is, so we'll have to place the ball in the origin. So I'm going to draw the directions now. So let this direction be eastward. This direction is north, east, west, then south will be this direction here. This is south, and then the up is this direction. Now, so it's shown, so the ball is thrown upward into the air with a speed of 30 meter per second with the angle of 30 degrees per ground. So this is where the ball is thrown. And it makes an angle of 30 degrees. So to be slightly more justifying of 30 degrees, I should draw it Okay, so this angle here is degree. So we want to find out what will be our, so then in this component, it will be 30 cos t, right? So let's find that out. So ball is thrown with the mass 0.8 kg is thrown southward. With this, a wind applies of 4 Newton uh, west wind. Okay, so the wind is in this direction. Yeah, it's flowing and applying a steady force of 4 Newton to the to to ball in eastern direction. All right, so this is a wind happening on this side. And where does the ball lands and with what speed? All right, so first of all, we need to understand what the acceleration is. And then we need to understand what the velocity is. And then we'll basically discuss the position. And from the velocity vector, we'll get the speed. All right, so let's see. So this is going to be, so let's take this as direction of I, this be direction of J, and then by right hand rule, this is the direction K. Okay. And now what we get is the following. So what is the force acting on the ball? So force acting on the ball is forces. So mass into acceleration equals to force, right? Now this force is acting in the direction of, so there's a force, there's a wind which is flowing in what? The wind is flowing in, pushing it in the eastern direction. So wind is flowing from here to this direction. So it says essentially AX, so MA equals to AX, FX, and what is your wind? Your wind is basically, so we have this is 0.8, we have, now this is not a vector because I'm looking at the component of it. So AX equals to Fx, which is given to us as 4 Newton. So we get AX equals to 4 by 0.8, which is going to be 5. So AX is 5. All right. Now what we need to do is, so AY is 0, right? There's no wind in the, so there's nothing along Y direction. So it is 0, right? And AZ, there is a gravity working downwards. So that is going to be minus G, which is 9.8. So your acceleration vector A is 5, 0, 9.8. This gives us velocity is 5t, 0, 9.8t plus c1, c2, c3. These are constants of integration. All right. So now what is V of 0 though? V of 0. Now V of 0 is, now when you look at 0, the essentially you have a force of, so this vector is your V of 0, Now it makes an angle of 30 degree with negative j. So it's going to be, so v of 0 is going to be minus 30, because the force is also 30 meter per second. So 30 cos 30. Now, what about the k component? So there's a component along this vector as well. So the component will be 30 sine 30. And the x component along the eastward, there is no component of this wind because this is going to be 0. So we get to this. So this is our v of 0. Now this implies, when you put back your v of t, so this would imply your v of t is simply 5t comma minus 5. So cos 30 is root 3 by 2, so you can cancel those 2's off. You'll get minus 15 root 3. And then we have, this is again 15, so 15 minus 9.8. So this is your v of t. So let's continue this process here. So we got v of t to be this. So therefore, what's r of t? R of t is integration of v of t. That is 5t squared by 2 minus 15 root 3. So if I write it in the rectangular bracket format, 15t minus 9.8 t squared by 2 plus constants alpha 1, alpha 2, alpha 3. However, so we have r of 0 is 0 vector, right? So that means when you put 0, you get everything becomes 0. Therefore, r of t equals to 5t squared by 2 minus 15 root 3t comma 15t minus 9.8 t squared over 2. So this is your r of t. Now, when does the ball lands? So when does the ball lands? So ball will land when you are in the xy plane. That means what? When the kth component becomes 0. So ball lands when kth component is 0. That means 15t minus 9.8 by 2t squared equals to 0. This gives me t equals to 30t. Sorry, so I need to take out t common. So the ball lands when this implies t times 15 minus 9.8 t by 2 equals to 0. Now t equals to 0 is the first starting point, so the ending point will be given by this component here. So we get 9.8 t by 2 equals to 15, or 15 t equals to 30 divided by 9.8. And that is roughly equals to 3.0612. Okay, so this is when the ball lands. This is the time with which the ball lands. And where does the ball lands and with what speed? So where does the ball land? So this is the first one. When So this is the time. So where does it land? So where does the ball land? So where does the ball land? So that's the first question. So we have R of 30 divided by 9.8. When you put this, we will get the value, which is here. We have to substitute in this equation. We have 5 times 30 divided by 9.8 square minus 15 root 3 times 30 by 9.8. And of course, the third component is 0. Yeah, so this is where the ball lands. And what is the speed? So the speed at which the ball lands, speed of landing is v of 3.0612, absolute value of that. And that turns out to be that turns out to be roughly 33.68 meter per second. Yep, so this is how the game is played. Now you can do the same thing with B as well. Thank you for your attention.